when you're building airplanes, it's real expensive. We use them a lot in airplanes, but we make them ourselves because we're going to make a 2-inch wide tape on this, and then we're going to make a 3.5-inch wide tape, and then maybe a 4.5 or 5-inch wide tape. You put the narrow ones first, and then wider and wider tapes. And the reason being that the fiberglass cloth, or little fibers on the end, will stick up and be sharp as razors. And if you put your second layer on that covers that edge, then none of those can stick up. Only the last edge can stick up, and you have to sand that. And you would lay your you take a piece of polyethylene, put it down, and wipe some. Actually, just pour. Just take a cup and pour it one end to the other. Put your narrow piece, your next piece, your next piece, your next piece, whatever. Then you put another piece of plastic on top, clear plastic on top for sure, because you have to be able to see through it. Bottom can be green, black, or clear. You take a squeegee and you rub it back and forth. All the fiberglass disappears into clear. Then you can peel off one of the layers of plastic, take it over, flip it so the narrow side is down, and just lay it on the seam, and then work it back and forth and work the excess epoxy to the edges, and make sure you haven't got air bubbles in it. Generally, you put a piece of something down the middle, just enough to be sure it's stuck together, or you can glass the outside. Just take a piece of sandpaper, run down there and round that corner just a little bit, and put your tape on the outside. Outsides don't generally require any kind of a fillet. This boat does not require fillets on the inside. If you have a square corner, then you have to put something in that shape in there so that the fiberglass can make that rounded curve. It's not strong if it goes right into the corner and back out of the corner. And it'll get air under it when you're trying to poke it in there with a squeegee. You walk back 5 minutes later, there's a bunch of air bubbles. Sometimes it's outgassing of the resin, but generally it's just the glass is moved and it sucked air from the back side or whatever. Anyway, you're gonna have a bunch of these pieces, and you put the stitch and glue together. Okay, come over here. How many of these are actual sheets? Okay, the actual sheets for the boat is on the left. This boat's 24 feet, and there's 1, 2, 3, 4, 5, 6, 7 pieces of 7 sheets. This boat's 18 feet. This one's only 18 feet. I can tell because I'm using 10-foot sheets of plywood, and there's only one seam on a lot of the sides. Okay, now the printer that we go use at Bacor, it's a 42-inch printer, but we can only print 38.5 of actual print because they don't want to get any ink on their rollers in the machine. So what we do is we draw 3 lines down here and make a copy of the print right over here. Just surround it, copy, put it over here. You erase everything above the upper line on one, and you erase everything below the lower line on the other. So you get a piece, that's this, minus that edge. And then you take all those edges down here at the bottom, and you make a print of those edges. And the reason you have 3 lines is so you can cut some V-shaped notches in your paper when it's printed, and you can see the line underneath. And then you put 2-inch cellophane tape down there and stick it back together. I can't make that more clear by repeating myself. Then you stick it back together. Put tape on both sides. See this panel here. Well, they're not going to show individually because I got them grouped, so I can't slide them around and mess them up. But you got 3 lines, and the center line, you're going to cut notches down to that, and then look for these lines sticking through. And there'll be a perimeter line around this. This is not the edge of the paper. This is the edge of what we print, and that gives you a point that you can line up with the other drawing. If you just cut the corner off of this one, lay it on the other one, that corner will be showing on the half you're sticking on top of. And there's a whole bunch of bulkheads in this boat, just to make it watertight compartments. And you can see that some of the smaller parts up here have the same kind of a joint. You know, I call them kayak joints. I don't know what they come from. But if you buy a kit kayak of that 1/8 inch thick plywood, they're laser cut. Or they're stamped with a knife blade, you know, a tool. They're making a lot of them. Oh, and these, when you get to this stage of the drawing, you put names, what the part is. You don't need the name. Doesn't do much anything other than makes you organize things better. We're back to number 3. That's the same part we started with, but it's in the drawing. So the actual sheets are on the left, the 4x8 sheets. So 1, 2, 3, 4, 5, 6, 7 sheets, and you can tell that the sheets are pretty well completely full of stuff. There's not a lot of airspace around these parts. There's like 5/8 to 3/4 of an inch. So you can take this piece. You got the pieces cut, but you got to put them on a plywood. So you take it and you drag one over there, and you get one place that's close, and then you rotate it around till this end hits there. Then you can slide it out a little bit, and then you get another one. You put it in there, and you pick a point, swing it around, move it up and down, left and right until it fits in there where you want it. And you just keep finding parts that fit in the space you got. This is done in what's called computer-aided design. You still got to design it. Although with stitch and glue boat building, it's more that looks good to me than engineering, because you're going to use the same thickness of plywood no matter what, and you're going to use the same kind of resin. You're probably going to use the same cloth. I wouldn't use chopped strand math on something that's light. It would weigh 4 times as much as the rest of the boat. But you could, you know, if you wanted to. Sometimes you got some airspace, like there's one down here at the bottom. We got some airspace. That one is an example of one with a lot of, you know, big bulky pieces. I guess this would help when you were trying to line up these things here. They're mirror images, so they'll be exactly the same. A bunch of stuff went together here. You know, when you run out of plywood, you start just taking your repetitious curve here, drop it over it, and what do you call that? Let me look here. Split. There's a toolbars all around this drawing. Like 50. Oh, and for if you want to draw the thing, and put all the little holes where you can drill them. You don't have to do that. You can put it together by drilling the holes as you go. People do that. They put the 2 bottom halves on top of each other, drill through them because they're guaranteed going to fit, and the rest of them you drill the holes in one side. As you're putting your wires in to pull the edges together, you drill the other side 1 hole at a time, or maybe 2 holes at a time. So it's possible to do that without a CAD machine. CAD programs, you pay for them or you use free ones. The best known free one is called SketchUp by Google. You download it from google.com. It's an app. I don't know if you can use it on a phone. The screen's so small. I would install it on a laptop or a desktop. It doesn't need any real processor power. My computer that I have in the States is golly, 6.4 gigahertz, 4 cores, ammonia cooled, so liquid cooled phase change, and the main board has got the processor and the north side bridge are both liquid cooled. The video card's actually air cooled. It takes up 4 slots, and it's got PCI enhanced slots. Takes 4 of them. Mostly, not all for pins. There's only 2 slots for pins. The rest of them are just space because there's 123 processors standing on edge on it. It's an Asus, and it's got a massive fan that cools it. And then there's case fans. But this thing was so I can fly a simulator of aircraft designs. And you start off with a prototype, and we're going to do some of that, I think. We're going to do another video on things we do for fun, and I'll show you the airplane we designed. And we're actually building it. It's in process in the States. But you need a lot of processing power because what the simulator I use is X-Plane, and it divides the entire model into little strips. And the program was originally designed to design aircraft propellers, where the airfoil changes from one end to the other, and the angle of attack, that's the angle it meets the wind at, that constantly changes. So they use this blade element theory to make a simulator that simulates the whole plane and the control surfaces and the landing gear up and down and the propeller for the plane. And you have to specify everything. But they have models come with it if you just want to fly planes, like a Cessna or a bomber. I don't care what you want to fly. Somebody's made one and put it in the database. You just download it. It's free. Some are pay. Some that people do, you have to pay. Okay, we're going to end this video and we're going to go to another example of the drawings of a different kind.